Hello and welcome to Binpipe. My name is Prasanjit Singh and today's session will be about Google Anthos. Companies nowadays are struggling between moving to the cloud or staying on premise. That's the confusion. Companies would like to adopt the cloud in their own speed alongside with their on-premise infrastructure. The hybrid infrastructures provide companies to choose the best of both worlds and create a custom infrastructure which they can tailor for their own needs. Now, alright, taking this for granted that hybrid infrastructure is the best, because even if you are moving to the cloud, you cannot move the entire thing overnight. So there would be a phase in the migration life cycle where some of it would be on-premise, some of it would be cloud. But there are challenges there. We'll come to that in a while. In a recent study, Google concluded that 73% of the organizations use cloud and just 10% have moved their workloads completely to the cloud. So cloud introduces overhead with the need to manage different environments. Also, if you move to cloud, a standard tooling set is required. 80% of those who have moved to cloud have moved workloads back on premise because it proved to be operationally expensive to run in the cloud. According to it, 80% of enterprises have their hybrid cloud plans, but they are unsure. Analyzing this data, it turns out that the major challenges are have the lack of standardized tooling, a standard software or a dashboard or a framework that would manage hybrid cloud environments or multi-cloud environments or on-premise plus cloud hybrid, this kind of environment. So that tooling is missing, and the technology is missing. Like, there is no single de facto standard that can support a continuous migration or infrastructure modernization. So there comes in Anthos. Google Anthos tries to solve these problems. So what is Anthos? Anthos is a hybrid and multi-cloud solution powered by the latest innovations in distributed systems and service management software from Google. Now, Anthos, in simple words, is an application modernization and delivery platform offered by Google Cloud Platform. And Anthos is composed of several components that can work together to help you build and manage modern hybrid applications across environments. The solution is fully integrated with centralized management through a central control plane that supports policy-based application lifecycle delivery across multiple clouds. So what Anthos does, it brings on-premise and public cloud together, and it provides a common config management platform. It provides a service mesh that can connect your on-premise to your public cloud infrastructure, making it feel as if both are on the same network. So that is a component. And another component is it provides a container orchestrator that is again infrastructure agnostic, and you can deploy your containers on premise and on public cloud and even on multi-clouds, so your entire workload is taken care of. Now that we know what Anthos is, let's discuss how different moving parts of Anthos work. So what I'll do is I'll attempt to explain you how different Anthos moving parts work together. So we'll take a deep dive and understand and demystify everything around Anthos. So first thing is, as we discussed earlier, the container orchestration. Now, the primary computing environment for Anthos relies on Google Kubernetes engine, and GKE on-prem to manage Kubernetes installations in the environments where you intend to deploy your applications. Now these offerings bundle upstream Kubernetes releases and provide management capabilities for creating, scaling and upgrading Kubernetes clusters. Now Kubernetes has two main parts, as you all know, those who are familiar with Kubernetes, a control plane and a data plane, or the node components. Now with GKE, Google Cloud Platform hosts the control plane, and the Kubernetes API server is the only control plane component accessible to customers. GKE manages the node components in the customer's projects using instances in Compute Engine. With GKE on-prem, all components are hosted in customers' on-prem virtualization environment. And with Kubernetes installed and running, you have access to common orchestration layer that manages application deployment, configuration, upgrade and scaling. So Anthos forms a hybrid ecosystem for this entire container management, with underlying layers having Kubernetes, its data plane and the control plane and so on. Now that is one part. Then comes the centralized config management that we discussed. So what is under the hood for the centralized config management? Spanning multiple environments adds complexity in terms of resource management and consistency, because Anthos will span multiple environments, because Anthos is not just running on one cloud, it is giving you an aggregated view of multiple clouds and on-premise environments. So spanning multiple environments makes it more complex in terms of managing resources and keeping control of configurations. So Anthos here provides a centralized config management and provides a unified model for computing, networking and service management across clouds and across data centers. So that is how Anthos helps here. Configuration as code is a common approach to managing complexity, so Anthos provides just that, and it provides configuration as code via Anthos config management, and this deploys Anthos config management operator to your clusters. So this acts like an agent there running in your clusters, and it allows you to monitor and apply any configuration changes that is detected in your repositories. So if there is a push in your Git repo and a config change there, so automatically your config management operator present in your clusters will inform the central Anthos control plane that there is a change, and that change needs to be applied in these clusters, and that gets applied. This approach leverages core Kubernetes concepts such as namespaces, labels and annotations to determine how and where to apply config changes to all your Kubernetes clusters, no matter where they reside. So you have a repo which has a version, secure and controlled single source of truth for all your Kubernetes configurations, and this comes as a YAML or a JSON file, and these are applied with kubectl commands that can be managed with Anthos config management operator and applied to Kubernetes cluster using the Anthos config management. Now so that is all like how config management occurs. In short, there is a agent, config management operator, and you have your YAML files or JSON files with your configurations, and Anthos config management allows you to manage those configs across your diverse environments. So that is how it occurs there. Then comes another moving part of Anthos, which is the service mesh. Now what is a service mesh? The term service mesh is used to describe the network of microservices that make up such applications and interactions between them. As a service mesh grows in size and complexity, it can become harder to understand and manage. Its requirements can include discovery, load balancing, failure recovery, metrics and monitoring, and all these features. So a service mesh also often has more complex requirements, like you can have load testing stuff, and you can have canary rollouts, you can have blue-green deployments, rate limiting, access control, end-to-end authentications, and all that. So a service mesh is you can say a gateway or a proxy or a router that connects all your services, but it is not just a simple router that does a load balancing or proxifying or reverse proxying or forwarding traffic. It is an intelligent router that can discover your services, that can form associations, that can do canary rollouts, that can secure your environment, that can block traffic that is unwarranted, and so on. So very intelligent kind of a load balancer. Now this service mesh is an open source software derivation. It is called Istio. Now Istio provides behavioral insights and operational control over the service mesh as a whole, offering a complete solution to satisfy the diverse requirements of microservice applications. As the organizations increasingly start adopting cloud platforms, developers have to architect for portability using services, while operators have to manage large distributed deployments that span hybrid and multi-cloud deployments. Istio helps in reducing the complexity of managing service deployments, and it provides a uniform way to secure, connect, and monitor microservices across these environments. So Istio on Google Cloud Engine manages the entire Istio in GKE, providing all the benefits of open source Istio without the complexity of having to configure or install or upgrade the certificate authority setup and all that. So it's fully managed Istio, so you can just use it. Now you might be thinking, why use Istio at all? Now Istio, to sum up, number one, helps in automatic load balancing for HTTP, WebSocket, TCP traffic, and so on. Number two, it allows you to do a fine-grained control of the traffic behavior. You can write rich routing rules, you can route according to geolocations, you can block traffic coming from a certain IP address, stuff like that, and you can put in retry rules. For example, if a certain request to a certain API endpoint is not responded or gets a 500 error, then retry a couple of times on a fallback API, stuff like that. So you will have a failover and a fault injection mechanism also, which Istio will allow you to have fine-grained controls on. Then comes number three, a pluggable policy layer and configuration API supporting access controls and rate limits and quotas and so on. And number four, Istio allows you to log your events, like whatever traffic goes in or goes out through Istio, it's logged. So you get your metrics and traces for all the traffic that moves around in the cluster, ingress and egress. And finally, Istio allows a secure service to service communication in a cluster, and everything has is based on strong identity based authentication and authorization. So no chance of attacks and any manipulation of traffic. So it's a pretty useful piece of addition in the Anthos platform. In short, gives you security, observability, allows you to manage your traffic, helps you in platform support by allowing you to converge multiple heterogeneous platforms, and easy to integrate and customize, and finally allows you to build your architecture based on this load balancer come traffic forwarder. So how will services communicate across clusters, regions and environments? Like now we know that it is multi-cloud, that's fine. On-premise plus cloud hybrid, that is also fine. Now this hybrid can span up to multi-clusters, multi-regions and multi-environments as well. So like you might have three, four different Kubernetes clusters spread across different regions and across multiple clouds, hybrid clouds and so on. So when things become more and more complex, how will the services discover each other, identify each other, talk to each other? So for applications up to a certain size, all the microservices comprising the application can be run into a single orchestration platform, just like we discussed, a single Kubernetes cluster. However, for many reasons such as scale, redundancy, compliance, most applications will eventually need to be distributed, and then data governance and managing this infrastructure becomes difficult. A multi-cluster service mesh is the solution there. So you can have a multi-cluster service mesh or a multi-cluster Istio. So there what happens, you get a single administrative control and you have a shared control plane. In this kind of a configuration, if you look at this image, there are two clusters having a shared control plane, like a Kubernetes control plane running a remote configuration connects to a single Istio control plane. Once one or more remote Kubernetes clusters are connected to the Istio control plane, the remote envoys can then communicate with a single control plane and form a single service mesh across multiple clusters. Now, instead of a shared Istio control plane to manage the mesh, when there are multiple control planes, so in these kind of scenarios, each cluster has its own Istio control plane installation, and each manages their own endpoints. So all the clusters are under a shared administrative control for the purposes of policy environment and security. A single Istio mesh across the clusters is achieved by replicating shared services and namespaces using a common root CA in all the clusters. Now, cross-cluster communication occurs over Istio gateways for the respective clusters. If you look at this diagram, here you can see there are different projects, different clusters, and you have each of them have their own Istio gateway, and that is how they work in a multiple control plane model. While the previous diagram, if you recall or rewind, you can see they use a single Istio control plane that is shared between both the clusters, Kubernetes clusters. So that's the difference. So sounds complex, but this can be handled by Anthos. So that's how Anthos makes your management easier. Now comes another factor. In multiple control plane configuration, each cluster has its own Istio control plane installation, and each control plane manages its own local service mesh. So services running outside the cluster are defined using DNS names belonging to a .global domain. The services running inside the Kubernetes cluster use a DNS name ending with a .local domain. So if you look at this diagram, you'll see the .local and the .global service names in the Istio control plane. Now the security across the mesh is done by establishing trust between services across clusters. So that is also managed internally in the Anthos. If you look at this diagram, you can see the root certificate which is common between the central and the remote cluster. Okay, so apart from that, there is another moving part of Anthos, that is consolidated logging and monitoring. Logging and monitoring are very important for getting the pulse of a application, like how it is doing, how it is working. So that is done by Stackdriver. Stackdriver logging provides unified place to store and analyze logs. Logs generated by the cluster's internal components are automatically sent to the centralized Stackdriver, and workloads running inside your clusters have logs automatically enriched with relevant labels like the pod name and the cluster that generated them. Once labeled, logs are easier to explore through advanced queries. In addition, audit logs allow you to capture and analyze interactions that your applications and human users are having with your control components. So that is something very useful here. And apart from that, the final thing, the killer feature is the unified user interface. The unified interface provides you a single stop shop for everything, for managing, governing your entire cloud infrastructure. So that is one of the most important features, you can say, because we all need a single platform to manage. You would not like to have your OpenStack dashboard for your private cloud, move on to a Kubernetes dashboard for another environment, move on to a AWS console for your AWS assets, then move on to a GCP console to see your GCP assets, its logs there. So everything distributed wastes time, makes it complicated, involves more people, and so on. So here you get a GCP console which provides you a secure unified user interface. The GKE dashboard provides a secure console to view the state of your Kubernetes clusters and your workloads. The GKE Connect will allow you to register your GKE on-premise clusters securely with the GCP, and you can view the same information that is available in your GKE clusters through the GKE dashboard. So you get a single interface to see both your on-premise and your cloud resources. So you can see that in this diagram here, and so that is how it makes managing your resources easier. Apart from that, you also have a dashboard for your service mesh. So Anthos service mesh dashboard will provide observability to the health and performance of your services, and you can attach a Stackdriver adapter to it. It's just a plugin, so that will control service mesh metrics and aggregates all the data for each service request and response, and then you can have it on your dashboard. So you get an overview of your services, services going critical, errors, latency, traffic, and all this information. So very useful. So that's why Anthos is beneficial, I would say, if someone is working on multi-cloud or a hybrid environment. Very, very beneficial. You do not have a second tool as useful as this for this kind of a task. Now, Anthos for development makes it easier for developer to view things going under the hood, and also it is Git compliant. There's a lot of support available in GCP marketplace to quickly and easily drop off the shelf product into the clusters. So helps developers immensely. Anthos also helps operation teams to centralize, manage and templatize their deployments and managements using the config management system, and helps DevOps teams as well, and helps migration teams as well, because of integrating the multiple environments or heterogeneous environments. It allows migration tasks to be easier. And finally, helps in security. It provides the ability to enforce security standards across your clusters, across the cloud, across multiple environments and so on. So makes it centralized, auditable and secure. So a very useful tool. I would keep learning more about Anthos and trying to use it in my own implementations, and once I learn more, I'll share it with you, of course, here. So keep reading more about Anthos as well on cloud.google.com, and come back and join me here at Binpipe for knowing more and for more interesting videos from the cloud, DevOps and SRE world. Thank you.